Hello everyone and welcome. So as I promised in the class, in this video I will solve all the 4 problems in your Wednesday homework, okay? And then hopefully you can watch this video, try to learn your mistakes and redo the Wednesday homework, and then after that you can hopefully do well on the Sunday homework as well. Alright, so here's the first question that I got in my Wednesday homework. Use the trapezoidal rule with n is equal to 4 to approximate this integral. So I already wrote the trapezoidal formula. It's all about using this formula, okay? So to use this formula, first thing that I taught you in the class is to find delta x, right? Find the width. So here I can see a and b, it's going from 2 to 0. So delta x will be 2 minus 0, b minus a over n. N is 4. So this is going to be 2 over 4, that means half. So the width is half. Okay, so that's my delta x. Right, then what I ask you to do is, remember, draw a straight line. So you're going from 0 to 2, and then you will have 4 intervals, 1, 2, 3, 4, 4 intervals. And now these points going to be, since the width is half, this is half. Right, and then from half another half is 1, from 1 another half is 1.5 or 3 over 2, and then from there another half is 2. So these are my points. So now it's all about plugging all these into the formula. So our function is, let's see, the function is e to the negative 6x cube. Okay, so let's do this. So delta x is half. Now remember, half divided by 2. So don't forget that 2. Maybe you forgot that 2 in your calculations. I don't know. So check it out if you made a mistake in this type of a problem. Fx naught is, you plug the first x value to the function. So it's e to the 0, right? I mean, if you substitute 0 here, 0 cube is 0. Negative 6 times 0 is 0. So it's e to the 0. Plus 2 times, don't forget, in the trapezoidal rule, you multiply the middle values by 2. Maybe you forgot that too. 2 times e to the negative 6 half cube. Plus 2 times e to the negative 6 1 cube. That's by plugging 1. And 2 times e to the negative 6 3 over 2 cube. Plus the last point, in the last point, see, in the formula there's no 2, no coefficient of 2. So then we can say it's just e to the negative 6 2 cube. And that's all. Okay, now it's all about using calculator. But before doing that, let me simplify this. Maybe you have made a mistake in simplifying that. So half over 2 is actually 1 over 4. Okay, so this is in the denominator, this is in the denominator. You can multiply both of them. It's 1 over 4. So then it's 1 over 4 times this entire thing. And if I use the calculator, okay, what I got is 0.487. That's the answer to my first question. Okay, so hopefully this is a pretty easy question. So if you got wrong, check where you made a mistake. Probably it's implementing the formula. I think either you made a mistake simplifying delta x over 2, or maybe you messed up with the coefficients of 2. Okay, right, so now I'll move on to the second question. All right, so here's my second question. I only wrote few parts of it, actually one part of it. I'll show you the other parts when I am solving this. Okay, all right, so in this question, they give me this integral, and first they ask me to find the given integral. That means you can actually solve this using integration techniques. It's not a difficult integral to solve. Okay, so that's what they are kind of asking you to do here. Okay, so to integrate this, I can take 10 out of the integral, right? It's 1 to 1 over x dx. We all know what we get if we integrate 1 over x. So it's 10 times integral of 1 over x is natural log x. Okay, absolute value x, and going from 1 to 2. Right, so now you just need to substitute 2 and 1. Now we can drop the absolute sign, because I mean 2 is a positive number, so you don't need absolute sign. So it's ln 2 minus substitute 1 ln 1. Right, so that's what I get. So ln 1 is actually 0. Okay, so then the answer is 10 ln 2. That's your answer. All right, so hopefully that should be easy. Even if you plug this into your into achieve, they should mark it correct. Okay, right. Now the second part, I didn't write the second part here. So in the second part, they asked me to use the trapezoidal rule with n is equal to 5 to approximate the integral. Okay, so let's do this slowly. I know I already solved a trapezoidal rule problem in the previous with the previous problem, but I think I might know where again you might have made a mistake. So first you need to find delta x. So delta x is going to be b minus a, so 2 minus 1 over 5. So this is 1 over 5. That's the width. So now draw the straight line. So it's going from 1 to 2. Okay, so it's 1. I'm going to use decimals here because that's going to be easy here. Okay, 1 over 5 is 0.2. So we need 5 intervals. So 1, 2, 3, 4, 5. Yes, 5 intervals. So then this is going to be 1.2, 1.4, 1.6, 1.8 and 2. So the width is 0.2. Right, and then yeah, it's just using the trapezoidal rule formula. So it's delta x over 2. So 0.2 over 2, that's coming from the formula. Okay, so this is delta x over 2 times the function. Now the function is, remember, it's 10 over x. Okay, maybe you have forgotten 10 in your calculations. I don't know. Maybe that's the mistake that you did. Okay, so it's 10 over x. So here it's going to be 10 over 1. You plug 1, right? Now 2 times, remember in trapezoidal rule, you multiply by 2, the middle value. So 2 times 10 over 1.2 plus 2 times 10 over 1.4 plus 2 times 10 over 1.6 plus 2 times 10 over 1.8. And the final one, you don't multiply by 2 and it's 10 over 2. That's it. Okay, that's all you have to do. All right, so check where you, if you made a mistake in that problem, check where you made your mistake. And the answer that I got is 6.956. They ask you to round the answer to 3 decimal places, so get 4 decimal places and round it. Okay, right, round it using the way that we usually round. Okay, so I know we talked about rounding stuff in a special problem, in error bound problem. We do that rounding only in those special error bound problems. Here you would round it like you would normally do. Okay, so right. Now part C in my question is, let's see, use midpoint rule with n is equal to 5 to approximate the integral. So again, the width doesn't change because you know the n is 5, so the width is 0.2. Okay, so I'm going to draw a straight line 1 to 2 and then 5 intervals 1, 2, 3, 4, 5. So yeah, 1.2, 1.4, 1.6, 1.8. Now you need to find midpoints because you're using the midpoint rule. So these are the midpoints. Let's mark them. Those are the points that we are going to use. This is 1.1. This is 1.3. This is 1.5. The midpoints 1.7 and 1.9. Those are the midpoints. So now let's use the midpoint rule. Super easy. Midpoint rule says it's just delta x times you evaluate the functions at the midpoints. There's, you don't multiply by any special coefficient values and no anything. Okay, we just evaluate the function at the midpoints and then multiply by the width. Width is 0.2, so it's 0.2 times 10 over x. So 10 over first midpoint is 1.1 plus second midpoint is 10 over, so 1.3. So third 10 over 1.5, fourth 10 over 1.7 and final one 10 over 1.9. Okay, so it's just evaluating the function at the midpoint. So remember the function is 10 over x. Okay, right? Yeah, and if I simplify this, what I got is 6.919. Okay, so that's the answer that I got. All right, so more than the answer, I want to show you how to solve these problems. And you already tried these problems. I want to see where you might have made a mistake. Okay, right, the next part, final part in my problem says, so use the Simpson's rule with n is equal to 6. Okay, so this is not going to be fun here. So delta x, it's going to be 2 minus 1 over 6, so it's 1 over 6. That's the width. Here I would not use decimals because 1 over 6 you have to round it up. You don't get nice decibels. Like 1 over 5 it's 0.2, but 1 over 6 it's not nice. So I would use fractions here. Now the straight line going from 1 to 2, 6 intervals, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, I have 6. So 1 plus 1 over 6 is 7 over 6. Let's see. Yes, and then if you add another 1 over 6, it's let's see, 8 over 6. Okay, if you add 1 over 6 to 7 over 6, yes, it's 8 over 6, and then this is 9 over 6, this is 10 over 6, yeah, this is 11 over 6, 12 over 6 is 2. So okay, it's not that bad. All right, so the width is 1 over 6. Okay, right. Now I just need to use the Simpson's rule formula. So the Simpson's rule formula is delta x over 3, okay, fx naught plus, it's 4 to 4 2. Remember, 4x1 plus 2fx2 plus blah 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 blah, and then the last one is just fxn, but the one before that should be 4xn minus 1. Okay, so now if I use the formula, delta x is 1 over 6, so you have to divide 1 over 6 by 3, okay, times fx naught is now 10 over, first point is 1, and the second one is 4 times, don't forget to multiply by 4, 10 over x is 7 over 6, plus 2 times the next coefficient is 2. Okay, so it's 4 2 4 2. 2 times 10 over 8 over 6, and then 4 times 10 over 9 over 6, and then 2 times 10 over 10 over 6, and then 4 times 10 over 11 over 6. Okay, plus the last one is just 10 over 2. Okay, there you don't multiply by 4 or 2 or anything. Okay, that's it. So 1 over 6 over 3, this is 1 over 18. 6 times 3 is 1 over 18, and the parentheses, I wouldn't simplify, I would just plug this into the calculator. Okay, because anyway you need the calculator, and if I do that I get 6.932. all right, so this is how I solve the second problem. Okay, so see whether you have where you made the mistakes. Probably it's using the formula. Okay, so check this out, and if you still have troubles, let me know. Now I'm gonna go ahead and solve problem 3. All right, here's my third problem. As you can see, I have not written the entire problem, but I'll tell you what are the questions that I have. So first question, they asked me to use midpoint rule with n is equal to 4 to approximate this integral. Okay, so let me do that. So the width is going to be 3 minus 0 over 4, so it's 3 over 4. That's the width. Okay, and I'm going to draw that straight line. So it's going from 0 to 3, 4 intervals, 1 2 3 4. So this is 3 over 4, 3 over 4 plus 3 over 4 is 6 over 4, plus 3 over 4 is 9 over 4, plus 3 over 4 is 12 over 4 is 3. Okay, so those are my points, right? Midpoint rule, or whoops, we need to find the midpoints. So the midpoints going to be here. One way that you can find the midpoints is that you can add these two endpoints and divide by 2. So here the midpoint is going to be 3 over 8. Okay, and then here the midpoint is going to be let's see, 9 over 8. Okay, here the midpoint is going to be 15 over 8, and here the midpoint is going to be, let's see, 21 over 8. Yeah, I think my values are correct. Okay, so those are my midpoints. So then let me use the midpoint formula. So the midpoint formula is just delta x times the functions evaluated at the midpoint. So delta x is 3 over 4. So it's 3 over 4 times the function is e to the negative 5x square. So it's e to the negative 5 times 3 over 8 square plus e to the negative 5 over 9 over 8 square plus e to the negative 5 15 over 8 square plus e to the negative 5 21 over 8 square. Yeah. So we don't multiply by any coefficients in midpoint rule. So if I plug this into my calculator, I got 0.373. All right. So that's the first part. Okay, now we go into the error bound part. So that's probably where you might have struggled in these type of problems. So the error bound, so they asked me to estimate the error in using the approximation. That's, you have to use the error bound and find that worst case error. Okay, so the error bound is error of midpoint is less than k b minus a cube over 24n square, right? So let's find k in a minute, but k times the other terms going to be b and a, they are 3 and 0, so 3 minus 0 to the cube over 24. What's n? N is 4, so 4 square times 4 square. So those things are easy, it's just finding k. So to find the k, remember it's the bound for the second derivative of the function. Okay, right? So now function is e to the negative 5x square. Now let's find the second derivative. Okay, so I'll show you now how to find the second derivative. This is from Calc 1, but I'll show it to you. So here you have to use chain rule. All right, first of all, because you have a function inside another function, so you differentiate what you have inside. So derivative of negative 5x square is negative 10x. Okay, you take 2 out. Okay, and then negative 5 times 2 is negative 10. You subtract 1 from the 2, and then this is 10x times e to the negative. The derivative of e is the same. Okay, so this is the first derivative, and then the second derivative is going to be, now you have to use product rule. Okay, so first differentiate negative 10x, so that's negative 10 e to the, keep e to the negative 5x square unchanged. Now plus over here minus, keep negative 10x unchanged, differentiate e to the negative 5x square. If we do that, we get negative 10x e to the negative 5x square, right? Okay, so then this is going to be negative 10 e to the negative 5x square, negative positive 100 x square e to the negative 5x square. So this is the second derivative. Okay, right, so now we have the second derivative. We need a bound for this. So what I told you is graph it. Okay, graph it between 0 and 3 and see whether it's an increasing function or decreasing function. So let's do that. So I'll show you how to do it in Desmos. So it's negative 10x e to the negative 5x square. Let's see, is that what I have? Negative 10, just negative 10. And then plus 100x, was it 100x? 100x square. Yeah, 100x square e to the negative 5x square. Right, let's see. Yeah, so that's what I have. So now it's going from 0 to 3. So let's see. So going from 0 to 3, oh, and then the absolute value. So I forgot that. We have to have the absolute value. Okay, so that's important because the bound is for the absolute value. So you have to consider the absolute values. Okay, absolute value of the function. So now it makes a difference. Okay, it will make the negative values positive. Now you have to see whether it's an increasing function or decreasing function between 0 and 3. So now you can see between 0 and 3, let's see. Yeah, between 0 and 3, it's kind of like oscillating. It increases and then go down and then increases and it decays. So you have to see where the maximum, where you can get the maximum. So here I can see this big peak is the maximum. So what's this point? It happening at 0, right? When x is equal to 0, the y value is 10. That's the maximum, right? So 10 is the largest in that interval. So 10 is the maximum of this function between 0 and 3. So k is going to be 10. All right. So then it's going to be the error bound. The error is going to be less than k is 10. 10 times 3 minus 0 cube is 3 cube. 3 cube is what? 27. So this is 10 times, yeah, 27. And then over 24, 4 square is 16. Okay, so let's see if we can simplify this by hand. So there are 3 9s and here there are 3 8s. Okay, and if we divide by 2, this is 4, this is 5, so 9 times 5 is 45, so 45 over 16 times 4 is 64. All right, so now it's all about plugging this into the calculator, and if I do that, I'm gonna get 0.703. so that's my worst error in this problem. That's the value. Okay, that's the estimation for your error. All right, so in part B, it's all about, maybe I think if you have made a mistake, it's I think probably going to be related to finding K. Maybe you didn't take the absolute value, maybe you didn't differentiate it correctly, so maybe something like that. So let me know if you need further more help. Okay, right, so part C, the final part, is you need to find the number of intervals that you need to guarantee. They say I want an error 0.00. Let's see how many zeros here in my problem. 4 zeros and a 6. Yep, that's what I have. Okay, so then we do the problem reverse. Remember, so it's k times b minus a cube 24 n square. Okay, this has to be less than 0.00006. Okay, so we know k is, so when we simplify, so we k is 10, b minus a cube, that's 27, right? Remember, 24, now n square. Now let's simplify these 3 9s, right? And 3 8s, and then this is 4. If you divide by 2, 5, so it's 45 over 4 n square, less than 0.00006. So switch, so n square to the right, this to the left, so 45 over 4 times 0.00006 less than n square. So I can simplify. Now you can plug this into the calculator and take the square root. That's okay, but I'll go a step ahead and show you how to rewrite this. Okay, if you had to do it like this in the exam or in a quiz. So this is 6 over 1 2 3 4 5 decimal places, so 1 2 3 4 5. Okay, so it's dividing by 100,000. So this I can take the reciprocal and multiply, so it's 45 1 2 3 4 5 zeros over 6 times 4 is 24, less than n square. Now take the square root of this, and if I do that, I'm gonna get, let's see what I get. I'm gonna get 433.01. Now here we round up. Okay, we don't say it's 433. Remember, we go one above, so it's 434. That's how many subintervals I need. Okay, so that's the answer I got. So this is problem 3. Okay, so hopefully this helps you to do well on the Wednesday homework and also in the Sunday homework. So there's only one more question to do. So let's see how we can do the final problem. All right, so here's my last question, the last question that I have. So first part, they asked me to use the midpoint rule with, let's see, with n is equal to 3 and midpoint rule to approximate this integral. So b is pi, a is 2 pi over 3. So the width is going to be b minus a over n. That means pi minus 2 pi over 3 over 3. So you have to be careful here a little bit. So to subtract this, I will multiply pi by 3, divide by 3, and then this is what I get. So if I simplify this, 3 pi minus 2 pi is pi, so it's pi over 3 in the numerator. Pi over 3 over 3 is pi over 9. That's your width. So you have to be a little bit careful with the simplifications. And then this straight line going from 2 pi over 3 to pi and 3 intervals. And then you add pi over 9. So that's going to be, this is going to be a little bit tricky. So this point is going to be 2 pi over 3 plus pi over 9. So to make the denominator common, I multiply by 3, numerator and denominator. So it's 6 pi over 9. So 6 pi over 9 plus pi over 9 is 7 pi over 9. 7 pi over 9. And if you add a pi over 9 for that, that's 8 pi over 9. And if you add pi over 9 to that, 9 pi over 9 is pi. So yeah, nice. Okay, now that's not the end here because we need to find the 3 midpoints. Okay, at least there's only 3. So let's see. So the mid here is going to be, so it's that you add 2 pi over 3 plus 7 pi over 9 and divide by 2. That's the midpoint. So here I can multiply by 3 both sides. So it's 6 pi plus 7. So this is going to be 6 pi over 9. So 6 plus 7 is 13. 13 pi over 9 means 13 pi over 9 divided by 2 is 13 pi over 18. Okay, so that's going to be the first midpoint. And the second midpoint is going to be 8 plus 7 is 15. So 15 pi over 18. Okay, and here it's going to be 17 pi over 18. That's the other midpoint. Yeah, okay, so now we have the midpoint. So let's use the midpoint rule to approximate this. So midpoint rule says it's delta x times, evaluate the functions at midpoint. So delta x pi over 9 times the function is 8 sine x over x. So 8 sine x is 13 pi over 18 divided by 13 pi over 18. Okay, plus then 8 sine 15 pi over 18 divided by 15 pi over 18 plus 8 sine 17 pi over 18 divided by 17 pi over 18. So that's the applying the midpoint rule. So this is delta x and the solar function evaluated at the 3 midpoints. And if I simplify this, I am going to get 1.640. That's the answer I got. Okay, so it's a little bit tricky that here it's just you have to deal with the fractions here. Okay, right, so you have to be you have to add fractions carefully. Now they ask me to do an error estimation, find the error using the approximation. So error is going to be, so in midpoint rule it's kb minus ao cube over 24n square. So here it's kb minus a is, let's see, b minus a, it's pi minus 2 pi over 3 cube over 24. N is 3, so 3 square is 9. Okay, now we just need to find k. So function is 8 sine x over x. Okay, so don't forget the 8. All right, so that's the function. You need to find the second derivative. So the first derivative is we have to apply the quotient rule. Okay, so the quotient rule for derivatives, remember, if you have a function h over g, if you differentiate this, you're gonna get, okay, square, you square the denominator, all right, and it's gx times the derivative of h minus h times the derivative of g. Okay, so that's the formula from Calc 1. So here it's x square, all right, and it's x times the derivative of sine is cosine, so it's 8x cosine x minus derivative of x is 1, so it's 8 sine x. Right, now let's find the second derivative. So to find the second derivative, you apply the quotient rule again. Okay, so we have to be careful here. Well, I'll need a lot of space. So dash x. Okay, so then applying the quotient rule to this again, you square the denominator. Square of x square is x to the 4. And here gx, which is x square, times the derivative of now the numerator. Okay, so derivative of 8x cosine x, you have to do product rule. Okay, so this is tricky. So derivative of 8x is 8, so 8 times cosine doesn't change, plus now keep 8x unchanged, derivative of cosine is sine x, now minus derivative of 8 sine x is 8 cosine x. So that was tricky. Minus now the derivative of the denominator, so 2x times the entire numerator, 8x cosine x minus 8 sine x. So that's a difficult second derivative to find. Okay, but yep, so x to the 4. Now if you multiply through, it's 8x square cosine x. If you multiply by x square here, 8x cube sine x minus 8x square cosine x minus here 2x 8x, it's 16x square cosine x, here minus plus a 16x sine x, 16x sine x. Right, so then the second derivative is going to be, let's see, 8x square cosine x, 8x square cosine x goes away, so it's minus 16x square cosine x plus 8x cube sine x plus 16x sine x. That's what's left over x to the 4. Now I can see I can cancel x because x is 1x from each. So what we have is x cube and minus 16x cosine x plus 8x square sine x plus 16 sine x. Right, I think I made a mistake here because the derivative of cosine should be minus sine. So this should be minus here. This should be minus, this should be minus, and this should be minus. Okay, that should be correct. Okay, so this is my second derivative. I think I gave you this in the class as well. I think it's the same thing. Okay, it's just maybe the coefficient that I gave you is different. Maybe you had, rather than 8, you had a different number. Okay, but yeah, this is my second derivative, right? So now you need to take the absolute value of this, okay, and graph it. So I already kind of did that. Okay, so this is the function minus 16x cosine x, like minus 8x square sine x plus 16 sine x. Yeah, this should be, let's see, that should be 16 sine x, right? Yeah, over x cube, right? Let's see what we get. So now we are looking at the graph from 2 pi over 3 to pi. Now this can be tricky because if you're using Desmos, you will see the whole numbers, right? You don't see pi and 2 pi over 3 and stuff like that. So it's just a rough idea is enough. Pi, you can think it like so, 3.14, okay, 3. Okay, here 2 pi over 3 is, it's 2 times 3.14 over 3. So you can see kind of like pi as 3. So it's like you're looking between 2 and 3. All right, so that's the idea. So if you look at between 2 and 3, all right, you can see between 2 and 3, it's an increasing function. See, between 2 and 3, it's increasing. Okay, so 2 and 3, it's 2 point, so it's, yeah, roughly in that interval. So if it is increasing, you're going to find the maximum at the rightmost point. So this is different from question 3. Okay, in question 3 we had nice numbers 0 and 3 as the interval. So we just look at the graph, see the highest peak, and between that interval we can get that number. But here the peak that you have here, it's not your k. Okay, because it's at 3.87, not at pi. All right, you need between 2 pi over 3 and pi. So all you have to do is you have to just get an idea whether this is increasing or decreasing in that interval. Here it's increasing. See, between 2 and 3 it's increasing. So you're gonna find the maximum at the rightmost point. Okay, because it's increasing. So what you need to do is you need to plug pi here. If you plug pi, that's going to be your k. You don't plug 2 pi over 3, it's pi, okay, because it's increasing. That's the idea. So question 3 and 4 little bit different. So let's plug pi, okay? So it's going to be, instead of x, we'll have pi. Let's see, I mean, we can use this as a calculator as well. And then let's see what we get. So pi cube. So what do we get? What's the value? 1.6211. Okay, so it's like 1.6211. So let's see, so that will be your k value. All right, or you can use the calculator as well, but I'm gonna choose that as my k. So k is 1.62. right, now you can find the error bound. It's k times b minus a cube over 24n square. This is 1.62. b minus a, it's pi minus 2 pi over 3 cube. 24, n is 3, so 3 square. So if I use the calculator, okay, I am gonna get 0.0086. So that's my verse error. Okay, that's my error estimation. All right, so finding k here is kind of the tricky thing because you're dealing with now pi and 2 pi over 3. They are not nice. So the idea is the important thing. You want to see whether it's an increasing or decreasing function. If it is increasing, you use the rightmost point. If it is decreasing, you use the leftmost point. Okay, so the final part is, now you need to determine n if you need to have 0.00006 error. So this is solving the problem reverse. So it's kb minus a cube over 2f 24n square now should be less than 0.00006. So here k is 1.62, b minus a, so it's pi minus 2 pi over 3 cube over 24n square should be less than 0.00006. So if I change n square and this, so it's 1.62 pi minus 2 pi over 3 cube 24 times 0.00006 should be less than n square. So now you just need to take the square root of this using calculator, and if I do that, I get 35 point something, but we round it up because we have to always round up in these problems. Okay, so it's 36. 36 is the correct number of intervals you should have to get this much error. Okay, right, so those are the 4 questions, answers to the 4 questions. Okay, but the idea is I think the most mistake is coming from when you find k. So let me know if you have any further questions. Okay, all right.